Hello and welcome back to Elementary Algebra section 2.6 on linear inequalities. So we are going to now work inequalities rather than equations. And before we do any of them, I'm just going to write like a little chart with names. So we know when you see something like 2x plus 3, this is just called an expression. Now, when you see 2x plus 3 equals 6, that's known as equation. And if you see it as 2x plus 3 less than 6, it's inequality. So these are the three structures, three creatures, okay, that you encounter in algebra. Expression doesn't have equal sign, and you can only simplify it. And if you are given x, you can compute the value for the expression. So you can't do much with expression. Expression is just there, right? And you can compute that if someone says, okay, if x is -1, how much is this, right? You plug in -1 and you're done. So expression doesn't have equal sign and it cannot be solved unless x is provided to you. 2x plus 3 equals 6 is called the equation, and as you can see, it has a variable x, and because it has equal sign, you can calculate x by subtracting 3, dividing 2, so all of your tricks from before. So you can solve the equation and get x equals, in this case, x equals 3/2 or 1.5. And finally, the last piece of the puzzle, which is what we are going to work on today, is this 2x plus 3 less than 6, which is inequality, and that one will be now our topic, where we are going to see that we are getting a lot of solutions rather than just one solution, like for equations. So again, the first one is just expression, and you can only simplify them, maybe, and that's it. The second two you can solve, where the equation gives you one solution, and you will see that inequality gives you infinitely many solutions, right? Now, before we dive into inequalities, we're going to take a look at these four symbols. This symbol, right, which is it's known as less than. And it literally means 3 is less than 10. Right? You read it that way. 3 is less than 10. You just want to have something that makes sense there. You're not going to say 3 is less than 1 because that's wrong. So you can make any example up as long as it mathematically makes sense to say the words less than in between those two numbers. Then you have greater than, and this would be 7 is greater than 2. Right? So that's that one. And now we have a less than or equal to. You can actually use this to say 5 is less than or equal to 5, because 5 is equal to 5, and that's okay. The equal sign is the part of this one. And we also have greater than or equal to. Which would be, let's say 10 is greater or equal than 8, for instance. So you can have these as the same number, or you can have them equal. See, you cannot say over here 3 is less than 3. Well, that's not good, because 3 is not less than 3. 3 is equal to 3. But you can say 3 is less or equal than 3 because the equal is also worked into the whole thing. This is actually used for tax brackets. We talked about money and we talked about these things. I'm just going to real quick pick up the tax brackets for 2020 and explain this concept or why you have two different types of signs. So tax brackets 2020, and let's say we're going to pick out the 12% tax. This is going to be single.
Mr. Nemanja, I have a
Yes.
question. How is 10 greater than or equal to 8?
10 is bigger than 8, right? If you have 10
Okay,
apples and
I know it's bigger than 8, but how is it equal to 8?
it's not equal. There is the or in between. So pick one of them. The only way to make this wrong is to say 5 is bigger and equal than 9. That's
Okay,
wrong.
so greater than or equal to.
Yeah, so you pick one of them. Okay, so for 12%, they say if you make between 9,876 to 40,125, perfect. And then 22% tax from 40,126 to 85,525. All right, so these are the tax brackets. This is the single um, uh, person you have married, jointly and all of that stuff. Married separately, which is again single rate and so on. But let's just take a look at single. So if you make, and you're filing your taxes as a single, if you make, let's say, $30,000 for a year, how much tax do you pay? What is the tax rate for you if you made 30,000?
12?
12%. And if you made, let's say, you are entry-level electrical engineer, you made 73,000 in a year, what's your tax rate?
22%.
22%, right? So how do you know this? How do you know this, right? How do you know that these are the percents?
Because 73,000 is more than 40, but less than 85.
Perfect. 73,000 is more than 4126. Excellent. Now, I also want you to observe this situation here. Do you see how they are the next numbers, right? It's a next number. So for the next tax bracket of 24%, you are going to have starting at 85,526, right? For the next tax bracket and so on. So, a lot of the political debates and all of these kind of things, they go back to these taxes. If you understand the majority, right? Democrats like higher taxes and more government, and Republicans like less taxes and less government. So that's their main, throughout the years. So the tax bracket over here at 12, 22, then the next one is 24%, right, and so on. And that's this time. Previous president, right, under Obama, it was 15% here, and this one was 25%. So as you can see now, this tax bracket is still lower than the previous one over there. So these are the main, right, and how they reallocate the money and so on. So when you are, if you're trying to understand politics and what are the main differences between the parties and so on, then this is just one of the dimensions on which obviously there is a foreign policy, there is a whole bunch of other things that you would have to consider. But when they talk in taxes and lower taxes or higher taxes, tax rate in Scandinavian countries, 50%, 60% of the money that you make goes to taxes, and then you are left with half of the money or less. So it all depends on what kind of a system you have, what type of government, and so on. So we see where this stuff is used. You can go on Google, type in tax bracket, take your paycheck, multiply your paycheck by number of paychecks you have in a year, which could be like 24 paychecks, right? Twice a month, let's say. And then you will have some idea on, which tax bracket you are in, right? And if you are close to the jump to the next, because this is 10% difference over here. That's a big jump for the next one to be 2%, right? And then says 4 more rows. So it goes 24, then 32, and then 35, 37. So there is this big jump here of 10%, but the next one is only 2%. Then the next jump is 8%. So it goes like that, and then 3% and 2% jumps for tax paying and so on. So there are a lot of things to consider, and we use inequalities to organize the numbers in a way where we know what's larger, what's smaller, and then to fit that into the category. And you guys said it great. 73,000 is more than 40,000, but less than 85,000, which means it's in between those two numbers. Therefore, it belongs to the 22% tax rate. Good. So that takes care of that. And then you go and now say, I know how to arrange my numbers. I know that 3 is larger than a half. I know that 10 is smaller than 100. I know that negative 3 is bigger than negative 10, because negative 10 is more negative than 3. So 3 is actually negative 3 is a bigger number. If you look at the number line, whatever number is to the left is smaller than the number on its right. So if I draw the number line and 0 and put my negative 3 here and negative 10 there, you see that, and we know that this is the way that larger works, right? Because this would be your 1, 2, 3, 4. So clearly larger goes towards the right. Then 10 has to be smaller than, negative 10 has to be smaller than negative 3 because it's to the left of negative 3. Sometimes people are confused with negative number comparisons. So make sure that you know that only whatever number is to the right is a bigger number, because the rule of ordering these numbers from smallest to largest is working this way, the way we count. And now we can involve into this, graphing statements on the number line. We said x is a variable that can take on any number as it has to, right? So variable, meaning this x could be 6, could be 10, could be million, right? It's going to be what it needs to be. But once I give it a value, then that x is that value. But I can also give it a range of values that I want to consider. For instance, I can say x is bigger than 3. Can you give me a value bigger than 3?
4.
4. Give me another one.
5.
Great. You can literally pick anything that is bigger than 3. This statement here means x is any number larger than 3. That's what the statement means. And you can graph it on the number line by putting up the open circle for 3 and then just shade all of the numbers that are bigger. Remember, there is a 4 there, and a 5, and a 6, and a 7. There is also 7.5 and 4.1, and all of the numbers, and a million. All of these numbers are bigger than 3. Now, you have over here 2 and 1 and a 0 and -1. Now, they're not shaded. See this line over here? It goes only over the numbers that are bigger than 3. And we have the open circle. I'll write that in blood over here. Open circle for less than and greater than, because the number 3 is not included in this. It's not equal. So I am not including number 3. Therefore, I use open circle. And then we're going to use filled in circle for less than equal, greater than equal. Because you can use for equal, right? You can use number 3. So now if I go and say x less or equal than 6, in this case you would go and you would find where your 6 is, and then you would shade all numbers smaller than 6, because I want all x's smaller than 6. And because I also want the equal, I close that circle because there is equal there. So all of the numbers like 5, 4, 3, 2, 1, 0, -1, all the way to -infinity this way, they're all in this bag of numbers that I do want, because I said all x's that are smaller or equal to 6. And I want the 6 as well. I want 6 as well because I have equal sign. Now, other numbers, 7, 8, 9, 10, going on forever to positive, what we call positive infinity. It's this number 8 sideways. That's infinity. All of these numbers are not considered because none of them is smaller than 6. None of these numbers, right, are smaller than 6. Pick 9, that's bigger than 6. Pick 10, bigger than 6. Pick 10.5, bigger than 6. So all of the numbers are bigger than 6, and that's why they are not in this shaded region. So with these two examples, you learned the way to graph the numbers, right? The way to graph the numbers, and whether you graph to the left or to the right, that is going to be, you stop and say, okay, common sense. Bigger numbers are to the right, I have bigger than, shade to the right. Smaller numbers are to the left, I have less than, so smaller, so shade to the left. Now, one student, this is a student with probably highly visual learner, said, oh, look at that, your x larger than 3 has this arrow pointing the same way as this symbol, and over here this arrow points the same way as this symbol. And I said, wow, in 30 plus years, at that point in my life, at 30 plus years of existence on this planet, and teaching this stuff for, and tutoring this stuff for almost 15 years, I have never seen that, or never actually ever mentioned that. And here comes this guy and says like, yeah, just look at that. It looks the same, right? So that's how I know which way to shade. And I said, okay, fine. If that is the way you're going to memorize and remember it, that's fine by me. One thing that you need to know, though, is that that only works if x is on the left all the time. Because I can make this statement the same if I write it this way. This is the same statement. but then, you know, you can't be graphing the other way. So if you are memorizing that the arrow going towards the infinity and the sign, make sure that x is on the left. You know, x must be on the left. That's the deal. Any questions, concerns about this?
Can you do one more?
Yes, yes, yes. I'm going to ask you guys to figure out x less equal than negative 4. So try this one on your paper, and then hopefully someone will guide me through on how to graph this. Anyone? What should I do?
I did like just the starting off with the negative numbers, -4, I guess.
Okay, so what should I draw?
I just put like a line with -4.
A line and then -4. Okay, here,
Yeah,
line
kind
and
of like the top
-4.
one. Yeah.
Is that
Sorry.
I have a line and I have a -4. So what now? What do I need to draw on the line first before I put -4?
Oh, the circle. Sorry.
Ah, nice. Okay, so what kind of
Filled in.
circle?
A filled-in circle.
Filled in circle. That's it. And now I know where to put -4.
Ready?
Awesome. And do I go left or right?
Left.
Left, because I want smaller numbers. Awesome. Done deal. Ta-da! Now, why are we learning this skill? It's because our equations now, called inequalities, will have a lot of these, we'll have solution like this, and then we graph the solution so we can quickly see where the answers go. So let's solve 2x plus 6 equal to, let's say, 18. Oh, sorry, less than equal to 18. I'm going to say here that rules to solve this are the same as in equations. So if I told you now that you will be solving this exactly the same way as if you had an equation, what would be your first step?
Subtract 6.
Excellent. That's exactly what you would do if you had an equation. So now 2x is less or equal than 12. What would you do then? What's the next step?
Divide by 2.
Perfect. So x less equal than 6. Looks like we have a new student. Now we have to graph this bad boy, because this is your solution, guys. That's it. You're done. So all I need to do is to graph it. So what should I draw? A line.
YouTube.
And then what?
Filled-in circle.
Filled in circle.
Filled in circle. And what value I'm going to put underneath?
6.
6. And then do I go left or right?
You're going left.
Why?
Because it's less than 6 or
Perfect.
equal to.
So this is where all of the numbers that are less than 6, that's where they live. So if I want to check this, we pick any number from here. So give me one number from there.
4.
Okay, pick x equals 4, plug in. So what do we have? We have 2 times 4 plus 6 needs to be smaller or equal than 18. Is this true? How much is 2 times 4?
8.
And plus 6 is?
14.
And 14 is?
Less
Smaller.
than 18.
And that's good, right? So
Yes.
we know that we have a good solution. Now, if you picked 10, let's say for some reason you shaded this way, and then you pick 10 to check. How much is 2 times 10?
20.
And plus
20
6?
plus 26.
Is 26 bigger than, smaller than 18?
Greater than.
Right? So you see that will be wrong.
Right.
So you can always detect when you solve these problems wrong if you pick a value and just check real quick to see that it gives you correct statement, right? So that's a cool part about this. Let's take a look at, and by the way, this is it. I mean, there is nothing else now. We just make these problems a little bit, more annoying, but that's it. We are done. So let's make it a little bit more annoying. 3 plus 2x less than 5 plus x. Solve it the same way as if you were solving the equation. What would you do first?
Combine like terms.
Excellent. So what do you do?
3 plus 5.
They're on opposite sides.
Oh.
So we first combine variables. So what would be the way to combine variables?
Subtract.
Great. What are you subtracting?
2x from x.
Can we do x like this? So we keep x's on the left. Right? So you remove the one on the right side to have your x's on the left. So now we have 3 plus single x, because 2 apples minus 1 apple is an apple. And you have a 5 on this side. Now what?
You subtract 3.
Perfect. And we have x.
X is less than or greater to 5. Oh, 2. Sorry, my bad. 2.
Okay. No, that's fine. So now for the graph, what do I do? Oh, by the way, you have to graph in every problem. It says solve and graph. Solve and graph. So this graph is going to be like 3-4 points out of 10. It's a big chunk, so you do not want to miss graphing. So on the line, what kind of dot do I put and where?
A filled in one.
Filled in dot, good. That's my number 2, and then?
Going to the right of the graph.
To the right, and now we check. So pick a number from here.
3.
Pick 3. So 3 plus 2 times 3 should be smaller than 5 plus 3. How much is 2 times 3?
6.
6 plus 3 is?
9.
And that should be smaller than 5 plus 3 is?
8.
Is 9 smaller than 8?
No,
Which means
can't do it.
can go to the right. Graph should go to the left. We need smaller values.
Do we have to, on the test, do we have to show like a check too? Or can we just like solve and then graph?
Depends on the problem. If the problem says, and you'll see it on my MATLAB, if the problem says check, then you need to do the check because it's the part of the problem. That's the thing. So checking the problems, right, being careful is important life skill. I mean, that's something that, you know, I understand this is not something that you would be, you know, happy to do. It's math, right? It's not the field of interest. But the good thing is that, you know, solving and checking kind of takes care of the situation of, yeah, problem is definitely right. So, yay, move on with my life. All right, let's make this a little bit more annoying because I guess it's so much fun. How about this? 3, 2x minus 1, no, 2x plus 1, oops, greater than negative, open parenthesis, 5 minus 3x. This is problem 75 in the textbook. Guys, same rules like equations.
Before we solve it, do you distribute the negative?
Excellent. I want you to try first. I'm not gonna jump in and, you know, do it. I'm going to give you some time to try it.
Do we get a fraction from this?
Could be. Fraction, decimal. Fraction and decimal, obviously, same thing.
If it is a fraction, do you want it to be put into a mixed number or?
Whatever, you can. And do the graph still, right, for it.
Okay.
What do we get when we distribute?
Uh, 6x plus 3
6x plus 3. Perfect.
greater than negative 5 plus 3x.
Excellent. So this negative is just going to change all of the signs inside. And now what do I do?
Combine like terms.
Combine like terms. Perfect. So we should combine variables first. And we should keep them on the left, hopefully. So what do I move?
3x.
Excellent. So minus 3x on both sides. 6 minus 3 is 3, so 3x plus 3 larger than negative 5. And then what do I do?
Subtract.
Okay. So how much is minus 5 minus 3?
-8.
Negative 8. What's the last step?
Divide them.
Divide by
Wow.
3. Oh, that was a high pitch. That was good. That was good. Sign that kid up for singing lessons. Wish I could do that. Negative 8/3. Now, some you asked, right? Should we make this into mixed number? If it makes you, right, happier, go ahead, right? So 2 and 2/3, because there are 2 3s in 8. So 2 groups of a 3, that's 6. And then the 2 is left over. So to graph, right, we use the
I'm sorry,
open.
can you repeat that last part? Next to the x, x is greater than -8/3.
That's the solution, yes. That's the solution. Now, if you want to move it into the mixed number, you can. Or if the problem on my MATLAB says move it to the, convert it to the mixed number, then you convert it into the mixed number.
How did you convert it into the mixed number?
The way I do it in head. I said, how many 3s do I have in 8? I have 2 3s in 2 groups of a 3. Right? If I have 1, 2, 3, 4, 5, 6, 7, 8, I have this group and this group. So that's 2 groups of 3. And then I have these 2 left over. And the denominator cannot change, so it's 2/3. So I have 2 groups over here. And then these 2 leftovers on the side. But you can also say 8 divided by 3 is, well, actually, no, in US you say 3 into 8. There we go. 3 into 8 goes 2 times with the remainder 2. Because when you multiply back, you get 6 and then remainder 2. So here is your 2, your remainder 2, and your denominator of 3. Like, it's a little bit convoluted, but, the more you practice it, it gets better. But we can use -8/3 here, so -8/3. And what do I shade, left or right?
Right.
Right, because that's where the larger numbers are. Right, x needs to be bigger than -8/3. And that's that part. We have one rule, and one rule and another example, and this rule is very important. If you divide by negative number, switch the inequality. So less than becomes greater than becomes less than equal becomes greater than equal, and greater than equal becomes less than equal. So your job is to switch the inequality if you divide by a negative number. Now, there are plenty of examples to practice this. I'm going to, we haven't had anything with decimals, right? So we can pull one of those here. And then this rule will also be there. So -5.1x plus 1.1 less than 0.1 minus 0.1x.
Yeah, I hate decimals.
Me too. We are in the same boat, my friend. Fractions are so much better, but you know what? Look at this. Each one of these numbers has exactly one decimal. If you multiply entire problem by 10, all of the decimals are gone. That's the perk of equations and equations and inequalities.
And then you would just have to remember to just put the decimal back in, I guess, at the end,
No,
or just,
because you are multiplying both sides of the equation by 10. You don't have to do anything later in the problem. It's just done. Once you multiply it now, you don't do anything later because you are multiplying both sides by 10. So that's one of the ways to deal with this. So we add 0.1 to both sides. And we get negative 5x plus 1.1 less than 0.1. Then we are going to subtract 1.1 on both sides, and we are going to get negative 5x less than, and then this subtraction here is negative 1. And here is the rule I just had up there. You are dividing by negative 5. Switch the inequality. So x will stay alone, but now this switches into greater than, and then negative divided by negative is 1/5 positive. So switch the inequality because you divided by a negative. I call this rule a grade slayer because you tend to forget this and then shows up on the test or the final, and it's a massacre. So make sure you do that, and then you draw your number line, filled in dot. No, open circle. Open circle here for the 1/5, and greater numbers are to the right. So please remember the rule to switch the inequality and any time when you divide by a negative number. So you have it here, right? I'm going to put it on a cloud.
Oh, so it's only when you divide by a negative number, but
Yes.
it doesn't apply if
It
it's a
could be
positive.
also multiplied by a negative number, but generally you just divide both sides by negative 5, right? It works also for multiplication by a negative number, but you pretty much never multiply because you divide both sides. So yeah. So anytime for inequalities. Now for equations we never had that because you don't switch equal sign into anything, right? It always stays equal. But now you have less than and greater than, and they actually switch. You can test that, by checking your answers later on. If you forget to switch and check your answer, you will get a wrong statement at the end. We need to discuss the date for the exam before we leave, and I will post in announcements what you guys decided for the exam. So let's talk about the exam.